Great job. Really, really great job. So we're going to do a couple of examples here to kind of cap off a little bit with 7.2. I'm going to jump into 7.3 a little bit. We're going to be back at the board a few more times here. Just going to try to mix it up a little bit and kind of get you to understand what we're doing with this. Basically, all it is arithmetic. It's just not simple. It's just not easy arithmetic, right? There's a lot of stuff going on. So I showed you guys 5 yesterday at the very end. I thought we'd start with that real quick. We've been working with multiplication. In fact, you guys just did what I would say is one of the more difficult multiplication type questions we'll do. And then, of course, number 5 is division. So with division, what I pointed out to you guys yesterday is that whenever you're dividing a fraction by a fraction, you use that old 6th or 7th grade thing, copy, dot, flop. Yep. And so this is kind of where we finished yesterday. We copied the first fraction, and then dot means you turn the division into a multiplication process, and then you flop or flip the last, or the second fraction there. So just the reciprocal of that, that's what flop means. And then you kind of have a choice right here. A number of things you could do with this. What I would suggest we do is the same thing we've been doing, and that's try to simplify it before you multiply it. So maybe we could do a little bit of factoring. What do you guys see as maybe like a useful factoring of 9?
3.
3 times 3, right? Yeah, so we could write that as 3 times 3 times x. What do you guys see as a useful, sorry?
Can you cross reduce?
Yeah, we're going to cross reduce here in a second. Yeah, I'm going to just show you the mechanics of it. 35. What would be a useful factoring of 35? 5 and 7. Yep, so 5 times 7 times y. 14, we could factor that as 2 times 7. 15 would be 3 times 5, 5 and 3, yeah. And then x squared would be x times x. You do not have to go to this level of detail. If you can just see how certain things are going to cross-reduce, that's fine. Let's check this out. When you do it this way, did you guys notice how this 7 could cancel with that 7? What else cancels?
3.
Yep. That 3 and that 3. This x and this x. You guys see anything else that cancels?
No.
How about this one? What about this 5 canceling with that 5?
No.
Why not? They're both denominators, right? It needs to be a top and a bottom, a numerator and a denominator to cancel. So that's not going to work.
Can it only be cross?
No, it could be vertical. Yep. Anything when you're multiplying like this, anything in the numerator with any denominator would cancel out. Okay, so then quiet down. Once you've done this, I think the leftovers become fairly clear. There's a 3 and a 2. When you multiply the numerators times each other. 3 times 2 is 6. And down low in the denominators, you've got a 5, you've got a y, you've got another 5, and you've got an x. So multiplying those together, 5 times 5, 25, x times y, yep, just 25xy. Okay. I always do one last check, just to make sure that there's nothing I left on the table as far as, I could have simplified it, could have canceled it out. I don't see anything between the 6 and the 25, so I feel pretty confident that would be my final simplification.
Wait, if there was, would it just be like that answer xy?
Well, I don't know, just depending on how the 6 and the 25 behaved with each other. It could be I could cancel a 2 or a 3 out or something. It doesn't happen in this case, but I just want to double check. What that means, it would mean that I didn't notice something before when I tried to do all my reducing at the start, which is possible. That's why I just do one last check, just to make sure I didn't forget or didn't see something.
All right.
Okay, so I thought what we would do now is we'd look at number 6, and let's realize that once we do a little bit of, like a tiny bit of work with number 6 is going to end up looking an awful lot like what we just did up on the boards for our warm-up. Okay, so let's go ahead and look at that number 6, and we'll do the little preliminary step, and then I'm going to let you guys see if you can replicate that really good effort you guys had on your warm-up. Okay, so Sarah said it. Whenever you got a fraction divided by a fraction, so that's what I'm going to do here at the start. I'm going to write x squared minus x minus 6 over 2x squared plus 9x plus 10. That's my copy. Here's my dot. So we're going to be multiplying. And then the flop would be 2x squared plus 15x plus 25 over x squared minus 25. Okay, so I'm going to let you guys try to finish that using your increasingly improving factoring skills. See how it turns out for you. Kenzie, we're faced with one of these simplify completely, divides, multiplies. We are going to copy.flop, I suppose, here, but then we're going to factor everything first. Before we do anything else, we're going to put a lot of effort into factoring. So I'm going to go through this step by step, and I'm going to factor this one on the left here. So do you guys see a GCF in that one?
No.
There are no GCFs in that one, so there's no GCF to come out. But it is a trinomial, so I'm going to come over here to the side, and I'm going to multiply 1 times negative 6, my AC, to get negative 6. My B is negative 1. Which two numbers multiply to work out there in the x? Negative 3 and 2. So what I do with that is that I take the original, x squared. Now I split the B, minus 3x, plus 2x, minus 6. I'm going to group the first two and group the second two, and I always add my groupings. Now what I'm going to do is I'm going to factor out the GCF. So GCF out of the first one is this. That's the leftover. Factor out a 2 here. There's the leftover. And I find that a lot of people get to this step right there, and they're like, I factored it, right? I factored it. No, you have not. It's still an addition problem, right? The way that you finish this off is to factor out the common factor of x minus 3. And when you factor out the common factor of x minus 3, your leftovers inside would be an x and a plus 2. So x plus 2 goes there. So I'm going to stop for just a second and give you all a chance to look at what I've done, look at what you've done, give you a chance to ask a question if maybe that factoring doesn't make sense. Do you have any questions? Okay, so what I'm going to do then is I'm going to write that over here, x minus 3 times x plus 2, and that's going to be my left numerator, and then I'm going to erase all this stuff over here if we're good with the factoring.
Yes.
Okay, so that's going to go away. Now I am going to try to focus on what I'm highlighting in red, which is right here. So this is the exact same process. Are you using that as a calculator? Okay, cool. Exact same process, 2x squared plus 9x plus 10, right there. What's my AC? And what's my B? Excuse me.
9.
So which two numbers work in this one?
4 and 5.
4 and 5. Okay, so with 4 and 5, I'm coming back. Sorry there, Braden. With 4 and 5, I'm going to split up the B. It's going to be 2x squared plus 4x plus 5x plus 10. I group the first two. I group the second two. Just go ahead and put it where it goes. There you go. No, where it goes is actually up there. There you go. Factoring out the GCF, 2x and x plus 2. GCF here is 5, left over with x plus 2. Again, looking at this so far, is this making sense? Any questions? Okay, last step then is to factor out the x plus 2. Leftovers, 2x plus 5. That's my factoring for that left denominator. Hey, just a reminder, whenever you're factoring, if you have any questions at all, how could you check to see if you got it right or wrong? You could just FOIL it out, right? Okay, so I'm going to write that over here. X plus 2, parentheses 2x plus 5, like so. So far, let me just be honest with you. So far, as I've factored this and I've looked around, you all have said, nope, I got no questions. I'm good with the factoring. This is still 100% true. Totally true. Okay, I'm going to focus on the orange one. The orange one is right here. Are you guys getting to a place where you recognize this a little quicker? What is it? It's a difference of squares, right? It's a subtraction problem with a perfect square minus another perfect square. So this one to me is a little bit faster. We could write this as x plus 5 times x minus 5. That's how that difference of squares pattern should always work for you. And then lastly, upper right, the one that's not highlighted, it's going to be a binomial. And I think it's going to be 2x and x. It's going to be a plus 5. Nope.
2x plus 5.
Oh, okay, hold on. Andrew, so what I did, maybe I mistakenly did this. Nobody was having any questions at all, so I thought I would go a little quicker. Should I slow down? Or which one are you looking at, Andrew? You just
I'm
said
looking at the one you're doing now. I'm
The upper one?
Yeah.
So you'll have a question on this one perhaps. Okay, cool. I'll slow down. So with that one, my AC would be 2 times 25, which is 50. My B is 15.
Yeah, this is
So what numbers work?
I don't know.
Okay. So let's think this through. What numbers? There's really not that many numbers that multiply to be 50. Like 1 times 50, but when you add those up, what do you get?
10 and 5.
10 and 5.
I haven't even done it.
10 and 5 is right. Thank you. So then when we split the B up, we get 2x squared plus 10x plus 5x plus 25. Makes sense now, Andrew?
Yeah, I got it now.
Okay.
I don't know why I was having so much trouble with that.
You know what? Sometimes there's a mental block where when you look back at it, it should seem obvious, but at this front, on the other side, it didn't seem so obvious. Okay, hey, listen up, please. Hey, it's sort of encouraging that you seem this relaxed. I hope that this is an indicator that, yeah, you just nailed this one. Shh, hey, quiet, please. Thank you. So if you've gotten to this point, you've done a lot of really good factoring. It's gone really well. Now it's time to start trying to cancel common factors out. Did you guys notice these two cancel? Those two cancel? Anything else cancel? The x plus 2's, yes. So now when you look, of the 4 factors in the numerators, 3 of them canceled, 1's left. Same thing in the denominator. So our final answer for this one would be x minus 3 over x minus 5. Sarah. Shh. Quiet down, please.
I know this is like wrong.
Hey, guys, I apologize for saying this. Hey, you got to quiet down. Hey, you got to hush. Sarah just asked a question. I can barely hear her. Go.
Okay, I kind of went farther and I like canceled off the x.
Oh, let's talk about that. You know what? Because I was about to bring that up. I think you bring up a very good point.
And then I
Isn't this...
positive.
I get it. I get it. Isn't this tempting? Sarah just brought it up. She's like, I thought I should cancel out the x's. Can anyone explain why that's not correct? It is subtraction.
They're attached to the.
They're separate.
Can you say it again?
It's like one single factor.
Yeah, you can only cancel out the whole factor or none of it.
Yeah.
Okay? So, I'm trying to think of a good visual here for you. I know it's tempting because the x's are right above each other.
But since they're different.
Something is Adam and Eve.
It's not even that. Like if it was, like if the question was different, like if it was x times 3 over x times 5, you can cancel those x's out. But notice the difference. Times is different from subtraction. Right? No? Yes?
Well, I don't know why.
Drop this on yourself.
Okay. It's just a different operation. So I'll show you.
Pretty much the same thing, right? Yeah.
Just multiply by 2. Just the 2 times 2.
No excuses. You should be just as good right now as you were at 10 a.m. on a Friday, or 10 a.m. on a Wednesday instead of on a Friday. Good. I'm glad. Hey guys, are we here? Kyle, you here? Looks like you are. Okay. Hey, I think you're going to find some of these early questions to be pretty straightforward. Let me just, can I give you a broad overview? Hey, I need your full attention, please. Let me give you a broad overview because I want you to understand what we're doing. I need to feel like it's quiet so that at least I have a sense that maybe you're listening. 7.1, we looked at fractions and we talked about how do you reduce fractions. Worked on that for a while. In 7.2, we talked about how do you multiply and divide fractions together. So doesn't it seem natural that in 7.3, 7.4, we talk about addition and subtraction? We're just running through all the things you can do with fractions. Add, multiply, subtract, divide, those sorts of things. Okay? So, let's work through this. I think you're going to find a lot of these to be very straightforward. So for example, the little saying here, it says, in order to add or subtract fractions, the fractions must have
Common denominator.
a common denominator. Yes.
Thanks, Kyle.
So I think it's really a good idea to compare right now. So listen really carefully to my words, because sometimes, like we talked about yesterday in math, we're tempted to ignore the words. I think the words are really important. When you are multiplying fractions, do you need a common denominator?
No.
No, you don't. You could, but that could be something that would happen, but you absolutely don't have to have that. When you are adding or subtracting, though, you do, right? And so Sarah, this kind of goes to your question earlier. We need to pay really close attention to the symbols and what they mean. For instance, this symbol here, of course, means plus, so we wouldn't want to accidentally multiply them, right? Sometimes that happens. Pay really close attention to that. So let's do number 1 together. I'll have you do maybe number 2 on your own. So with number 1, it says add x plus 9, or x over 9 plus 7x over 9. So in order to add, we need to have a common denominator. Do I already have a common denominator, or am I going to have to work for it? Already got it, right? The 9s match up. So the denominator is already a common denominator. So when you add fractions, what do you do with the denominators? They stay the same. Yep. So denominator is 9. It will remain a 9. What do you do with the numerators, though? You actually add them up. Yeah, so it'd be x plus 7x. What's x plus 7x? That's x times x. That's multiplication. 8x. There you go. This would end up being 8x over 9. You always want to double check to make sure that this doesn't need to be simplified. I don't see any common factors between 8 and 9. There's no x's that could be canceled out. So I would say that this one is done. I do feel compelled to say this in honor of our friend Andrew. Let's just take another shot at this and make sure we're super clear. X plus 7x versus x times 7x. Two totally different things, but they look really similar, and it's easy to get them confused. X plus 7x, you could say that's really, you could say that that's really like you have 7 x's, and somebody gave you another x. So how many do you have? 8 of them. But x times x doesn't give us 8x. It gives us x squared, so we'd have 7x squared there. We just want to be able to distinguish between those two for sure. Okay, why don't you guys flip over to number 2. Please try number 2 on your own, all right? Ready, set, go. Okay, we're doing number 2. So, walking around, I did not see that many fully correct answers. I saw a lot of almost correct answers. Let me explain what I mean. Shh. Hey, just listen. Watch. Ask questions if you need to, but listen to watch. I'm going to ask that you not talk. I don't think that that's asking too much. I really don't. You had plenty of opportunities to. Please stop. Did you guys notice that there's a common denominator already?
Yeah.
Okay, so we didn't have to do any extra work there. So all I really have to do is say, well, my final denominator is going to be 7x minus 14. But then when I add my numerators, 4x plus 2x is 6x, and negative 3 plus negative 9 is minus 12. That was definitely the most common answer that I saw as I walked around. And if you've done this, you've done nothing wrong. You're just not done. There's actually a little bit more you can do. You always want to ask yourself, could this be simplified? Could this be reduced? And you've got a factor in order to answer that question. What's the common factor in the top? 6.
X minus.
And then x minus 2 is the leftover.
7.
7 in the bottom, leftovers. So now, do you see the cancellation? Now that you've, listen. Shh. Hey. Now that you've factored, you can see your cancellations clearly, right? You can cancel this whole factor. I did not say that. I might have said be quiet or wait. I didn't say you couldn't do that. So then your final answer for this one would be 6/7. 6/7.
No, she's talking about what's that?
Oh, so Sarah, are you referring is DJ right? Are you talking about the previous one? Sarah, check this out. Hopefully this will be a good comparison. Sarah.
Yes.
Look up there. Can I show you what you cannot do? You can't cancel the minus 2's. You can't cancel the x's. What you can do is you can cancel the entire x minus 2 with the entire x minus 2 because they're both factors. What you wanted to do earlier was something like, what was it? X minus 6, or no, it was like x minus 3 over x minus 5. You wanted to cancel this with this.
And that's not.
Do you see how it's different? It needs to be the whole thing with the whole thing, but wait, I can't because one of them is x minus 3 and the other one is x minus 5. Do you see the difference? Okay. Good question. Any follow-ups?
That was the best carpet.
So your final answer here is 6/7. So come quiz or test time, if you didn't see the reducing there, you'd be out of point. You'd be out of point for sure. Because you got to simplify it. Simplify completely.
Yeah, I was just thinking one.
Probably 1, I'd bet. Yeah. I don't know. Probably depends on the question a little bit, but
Usually it's just more than that. That's why.
depending on how complicated it would be, this one is relatively simple. Okay. Hey guys, got a few more to do here. Obviously, you're having a little bit of a hard time staying focused. I don't know what to say about that other than let's try to focus. Yeah. Does it help you to know that you'll have a quiz on this next Wednesday? Well, find some.
Actually, let me try that.
So Keely, it was a fair question, fair answer. So if you can't find an extrinsic motivator like that, find one on the inside.
I will.
Okay.
I'm focused.
That's fine. Okay. Guys, this one's a little bit different. I want to kind of guide you through this one. I want to direct you through a little bit. Did you guys notice on this one here, subtraction, right? So it's a little bit different. But did you notice like the other ones, it already has the common denominator?
This one does too.
So whenever you subtract, the rules are the same. You leave the denominator the same. Please write this one out with me here if you haven't already. So we're going to leave the denominator as x plus 3. Here is where this one's different. Obviously, you know there's a difference between addition and subtraction. We want to be really careful with subtraction, right? I mean, how many times in your math career have you been like, oh man, I lost a minus sign? You want to be really careful with this. So here's how you handle this. X squared plus 10x minus. Can anybody guess the symbol that's going to be the most helpful here?
Minus.
Nope. We need to actually introduce a symbol in here.
Multiplication.
Minus.
No.
Division.
Parentheses. There it is.
So why don't you put this part here?
You could. It's not going to make any difference because you're not subtracting the first one from anything, but you are subtracting the second one from something. Okay? Yes, sir. That's why we put the parentheses in. So guys, here's why this... Hey guys, you need to distribute the minus sign. Absolutely, and here's why. We're not just subtracting 4x, and we're not just subtracting negative 9. We're subtracting the whole thing. The whole thing. And so Braden's idea of the distributive property is on the money. So that's what I'm going to do. We're going to distribute that minus sign to both. That's going to give us x squared plus 10x. And then it would be minus 4x. Almost no one ever misses that one. What's the part they miss?
Plus 9.
It's plus 9. Almost everyone that makes a mistake here, they forget that it's minus minus, and they just leave it as minus. It should be plus 9. Okay, so then for our final step here, maybe it's our final step. We'll see here in a second. We need to add those middle terms up there, and we get x squared plus 6x plus 9 over x plus 3. Is this done? No. Why not?
Factor.
We could maybe factor the top.
Ooh, we could try.
Why don't you try? Why don't you try? See what happens if you try to factor the top.
That's what I did wrong.
There's a little more to this one. Rosie.
So I got to this speed, but you can't cancel it out because then there'll be nothing on the top.
So this is x plus 3. It just like inexplicably changed to a 9.
Crap. I meant 3. I meant
Otherwise I would totally agree with you, but because of that, you actually can cancel.
Wait, so was it
This whole thing with that whole thing. Yep, you got it.
Wait, how did you get the 6x?
10x, 10x plus negative 4x. Does it make sense?
I forgot it was 10.
Oh, 10x, yeah. If you just had it as a 10, that makes sense. Yeah. Well, why is it 2x? I'm a little bit lost on the 2x part. Because it looks like you've just got x plus 3 times x plus 3.
I actually have a reason for this.
What's that? You did it right up to this point. I just don't understand the 2x part.
I just got confused. I thought that the X was on the outside.
No.
So it would be X plus.
Okay, let's check out how this finishes. Did you guys, for the numerator, see x plus 3 times x plus 3 over x plus 3? So now that you've factored the top, you've got the bottom there, I would say that this entire factor cancels with one of those entire factors, leaving you simply with x plus 3. So, before we wrap this up, I got about 30 seconds here. I want to just let you know what we're going to do on Monday. On Monday, we'll review the multiplication division thing again a little bit. But then, if you notice what's coming up next, take a look at the screen. You're adding fractions again. Well, what's different about that than what we did? We're going to have to get the common denominators ourselves. We'll dedicate Monday to that, okay?
Yeah.
All right, cool. I hope you guys have a great weekend. I will see you then.